In this video, I have discussed all the questions of projectile motion. In 2026, around 7 to 8 questions were asked. So I have discussed all the questions. So let's do one by one. Here you can see the question PDF I have kept. So if you need the PDF, you can download it from description box, and you try to attend the questions by yourself. So let's see at the end of the video how much questions you are able to attend by yourself and how much mark you are getting out of 32. Formulas I have kept here for your reference. Quickly have an overlook of all the formulas: time of flight, Hmax, range, maximum range, relation between range and Hmax. So just have an overlook of all the formulas. So apart from this, some other formulas are also there, but for this 7 to 8 questions, we can use this 10 formulas and easily we can solve all the questions. So let us begin with the first question here. So you can see that two projectiles are given with initial velocities at 15 degree and 30 degree. So initial angle of projection they have mentioned 15 and 30 degree with respect to the horizontal. So then the ratio of the ranges is very simple question. We know that range formula u square sine 2 theta by g. So using that, here we will put initial angle of projection as 15 degree. So 2 into 15, 30 degree, sine 30 is 1 by 2. So we are getting the first range as u square by 2g. Same way second range we can find out. Second range we will get r2 equal to u square sine 2 into 30 degree. If you substitute here, then we are getting u square root 3 by 2g. So simply now we have to divide r1 with r2. So what ratio we are going to get? 1 is to root 3. So very simple question. Root 3 is the right answer for this particular question. So let's move on to the next question. So here they have given x and y coordinates of a projectile as a function of time is given by x coordinate is given 24t and y coordinate is 43.6 minus 4.9 t square respectively. Then the angle made by the projectile with the horizontal when t equal to 2 seconds. See, this is very important question. So how to solve, like x, like how the x varies and how the y component also varies, the positions they have given. So we just need to differentiate. Like here you can see x is given 24t. So if I differentiate that, what I will get? I will get velocity along x direction, that is vx equals to 24. The velocity along x direction. So I am getting a constant value. So vx, and obviously it is expected. We know that velocity along x component, x direction is constant. Similarly, if you go for y component, then y direction, y component they have given y equal to 43.6 minus 4.9 t square. Just differentiate this, you will get 43.6 minus 9.8 into t, because t square differentiation is 2t, 2 into 4.9, 9.8 you are getting. So further, on substituting the value of time t, so here in velocity of x we need not to substitute because it is 24, directly a constant value. And here if you substitute, then we are getting velocity of y also 24. See here, velocity of y is 24, velocity of x also 24. So then easily we can find out the angle. Here you can see this is the angle. Right now the projectile, this is the angle, like theta is the angle. So theta, tan theta, what will the value? Vy by vx. So tan theta we can say here Vy, velocity along y direction, velocity along x direction at this instant, 24 by 24. So we are getting theta as 45 degrees. So 45 degree B is the right answer to the question. So question number 2. So 45 degrees is the right answer. Let's move on to the next question. Okay, so here they have given a gun is mounted on the ground and fires bullet in all the direction with the same speed. The farthest distance the bullet could reach is 6.4 meter. So maximum distance the gun can go is like the bullet can go is 6.4 meter. So about range they have clearly given. So the velocity of bullet from the gun is in dash meter per second. So you all know that for maximum range, what is the value of theta? 45. If you substitute theta 45, you will get the formula of maximum range as u square upon g. Range is u square upon g. So what you have to find out here? The speed of bullet from the gun. So directly you can find out range into g we can do here. So if you do u square upon g is given as 6.4. In the question 6.4 meter they have given. So u square will be how much? 6.4 into 10, 64. So u we are getting as 8 meter per second. Very simple question. You can see from projectile this year, direct formula based questions they are asking. So let us see here the next question. Two identical bodies they have given, projected with the same speed. So let's mark this one. Same speed they have projected at different angles. Angle of projection is different. Cover the same horizontal range. This is the quite important keyword here they have given. They cover same horizontal range for different angles with same speed. When that is possible, when both the angles are complementary to each other, then only possible. So if the time of flight of these bodies are 5 seconds and 10 seconds, time of flights they have given. 5 seconds is the time of flight for the first body, 10 seconds is the time of flight for the second body. Then the value of range is, range value we have to find out. So here you see, as per the question given condition, they have given initial velocities are same, so the angles are different. So here one thing I can write down, the angles will be complementary. Theta 1 and theta 2 must be complementary, then only the range will be same. So here further if you see, then putting the value, like here I have substituted theta and here I have substituted 90 minus theta, so as to, so both are like complementary angles. So here in one we have substituted theta, 2u sin theta by g, 2u sin 90 minus theta upon g. So as a result, if we multiply here both t1 and t2 expression, so you are getting 2u sin theta by g into 2u cos theta by g. This sin 90 minus theta, this expression, it we have turned into cos theta. Now carefully observe the RHS side. We have 2u square sin theta cos theta by g. Like here we can see that range formula is there. In this range formula is there, range. If you take this part, like we are getting u square, 2u square sin theta cos theta, so u square sin 2 theta upon g we can write down. So instead of that, this I have written now range, so we are getting t1 into t2 equal to 2 into range upon g. Okay, now whatever the information given, t1 value given, t2 value given, substitute that. 5 into 10 equals to 2 into r by 10, so g value also 10 we can take. Range we are getting as 250 meter. So here option A is correct. See, directly also we can remember this formula, t1 into t2, where t1 and t2 are time of flights for complementary angles, that equals to 2 into range by g. Those who do not remember, you can directly proceed by using the basic formulas. So this way also we can easily solve the question. Okay, so like this, easy questions are there in 2026 JEE Main, not much difficult. So let's see the next question. What is there? Question number, yet given a boy thrown a ball into air at an angle of 45 degree, 45 degree initial angle of projection given, the horizontal, and to land it on a roof of a building of height is h. So it lands on a roof whose height, the building height is h. If the ball attains a maximum height in 2 seconds, so this information is important. If it achieves maximum height in 2 seconds, then time of flight will be what? Time of flight will be 4 seconds here. So, and it lands on the ground, it lands on the building in 3 seconds after the launch. So then the value of h is, so it lands on that building 3 seconds after. So if you see the particular diagram here, here this is the initial angle of projection at 45 degree being projected. Now this is the maximum height, h max point. So to reach the h max, it takes 2 seconds of time. So total time of flight I can get here as 4 seconds. So now if we apply the time of flight formula, ts equals to 4 second time of flight to u y by g, because you all know that time of flight is given by 2u sin theta upon g. So u sin theta is what? U sin theta is the initial velocity along y direction. So in place of that, in place of ui, we have written 2 into ui upon g. So substituting the values of time and g here, we got the value of initial velocity along y direction, along vertical, as 20 meter per second. So further we have to find out what is the height of this building. This building is there, this building's height we have to calculate. So simple, here we can apply the equations of motion, s equals to ut plus half at square we can apply here. So using this s equal to ut plus half at square, now I am going to apply only along vertical direction, only along like vertical along y direction. So we have written everything along y direction, displacement along y, initial velocity along y, acceleration also along y. So substitute the values here. H we have to find out, in place of displacement along y we can substitute h, and y equal to uy equals to 20 into time equals to 3. Then further half into here g will be minus 10 because g is acting in downward direction. Always g acts downward direction. Initial velocity is in upward direction. So minus 10. So further solving this, we are getting the height as 15 meter. Okay. So like this here, option D we are getting correct. Clear all of you? So next question we will see, question number 7. Here they have given that an object is projected with kinetic energy of k from a point A. Like this is the point A. Here you can see this is the point A. Here the kinetic energy they mentioned as k, and from point A, like angle of projection they have given a 60 degree with the horizontal. Then the ratio of difference of kinetic energies between point B and at point C. So what is the ratio of kinetic energy difference from point B minus point C to that of point A? This is the question, right? Kinetic energy at C minus B by kinetic energy at A. So further if you see, velocity at A equals to u. So initial velocity of projection is u, and velocity at B position, at B point, if you check, velocity at B position will be only horizontal velocity will be there, no vertical velocity at highest point. So only we have u cos 60, that is u by 2. And similarly at C position, when it is going to strike the ground, again it attains the same velocity with what velocity it is being thrown. So at C position again the velocity is u only. Then further if you apply the kinetic energy formula here, then kinetic energy at A equals to half mu square. So that is in the question they have given that as k. Kinetic energy at B is how much? Half m into u by 2 square. So u by 2 square, like half mu square you write down, and 1 by 4 you keep separately, so it becomes k by 4. Then further kinetic energy at C equal to half mu square, again same kinetic energy k. So we have to find out kc minus kb. So kc minus kb is k minus k by 4 whole divided by k, that is kinetic energy at A. 3 by 4 k by k, so k get cancelled, we are getting 3 by 4. So option D, 3:4 is the right answer. So here the crucial point of understanding is, at the highest point only we have horizontal velocity, no vertical velocity at highest point. Horizontal velocity remains constant throughout the projectile. So the magnitude of velocity remains same. Initially what is the magnitude of velocity, and finally also magnitude of velocity will be same. So let's move on to the next question. Okay, question number 8, last question. See here, they have given the projectile is thrown upward with an angle of 60 degrees. So initial angle of projection 60 degree, and the speed of projectile is 20 meter per second when its direction of motion is 45 degree with the horizontal. So when the instantaneous velocity makes 45 degree with the horizontal, at that time the velocity of projectile is 20 meter per second. So the initial speed of projectile we have to find out here. So initial speed of projectile, see here, as per the given conditions, this is the initial direction of projection, and the angle initially it makes 60 degree with the horizontal. Now once it makes an angle of 45 degree at this point, the velocity here we have is 20 meter per second. So 20 meter per second will have a component along this direction, that will be how much? We all know that 20 cos 45 we can write down. So 20 cos 45, 20 by root 2. So here you can see that this is the horizontal component of velocity, 20 by root 2 at this moment. So initially what is the initial component along this direction horizontally? If you see, it will be also u cos 60. So this will be also u cos 60. So we all know that in projectile motion, horizontal component of velocity never changes. So here u cos 60 at this moment, and after some time 20 by root 2 both will be same. So we can write down u cos 60 equals to 20 upon root 2. So cos 60 is 1 by 2. So u by 2 is 20 by root 2. U we are getting as 20 root 2. So 20 root 2, option D is correct in this question. Okay, so here these all questions we have discussed in 2026. So all of you also go through the projectile motion formulas. So in the next video I will come with inclined projectile and projectile from certain height. Few more questions on inclined projectile and projectile from certain height, that is horizontal projectile, we will discuss. Thank you everyone.